Greetings, cerebral voyagers. I'm Dr. Weird, former chief cosmologist at the Sleepy Institute of Intergalactic Naps. In 1973, I taught the theory of everything to a cactus. It grew a second brain. Now let's get weird. Tonight, we dive into the ancient whispers of the cosmos and the beasts that slithered beneath forgotten oceans. So, grab your blanket, power down your neurons, and let the strangeness tuck you in. Before we begin, what mind-bending mystery should we unravel next? Drop your thoughts in the comments, and of course, subscribe to officially join Dr. Weird's Sleep Workshop. No quiz, just curiosity. What will be tomorrow every evening as we prepare to rest? We ask this question to ourselves. It is perhaps the biggest mystery. For all mankind, we can't help but wonder what the future has in store and worry about the uncertainties that may lie ahead. Everyone would like to look a couple of days or years ahead into the future and see what their life will be like. Will I be living the life of my dreams, or is something really painful waiting to happen? Well, what's the worst that could happen? To me, death shall ultimately claim us all. No one currently in recorded history has cheated death, and no matter how much we try to avoid it or delay it, death will come to us all eventually. Billions of years into the future, when the sun swallows the Earth, or whether a cataclysmic event like an asteroid impact occurs, our existence will dissolve into minuscule atoms scattered throughout the vastness of space. Moving haphazard through the cosmic expanse, we'll return to the very particles that once birthed us. Essentially, we'll once again revert to a state of non-existence. However, the universe will continue its progression. The sun will still rise and set on countless planets, seasons will change, and the tides will ebb and flow. Stars will be born and planets will form, sustaining the ever-evolving web of life. The cosmos itself will continue to expand and evolve over time. All events unfold as they have in the past, with the exception that this time your physical form has transitioned, rendering you unaware of the transformation. Consequently, you may not perceive the alterations transpiring around you. Thus, when you cast your gaze upon the night sky, remember that the stars above may be composed of atoms that were once integral components of a living organism. Space is a sin of possibilities. It is a realm where even the seemingly impossible can be possible. And there are moments when anomalies arise that are hard to explain in a universe governed by fixed mathematical forces. Just look at the night sky above you. Why do the stars, governed by these immutable mathematical forces, scatter themselves in a state of complete anarchy? Why don't stars repeat patterns in the universe? Could this unorderly arrangement be a cosmic message, one that has been overlooked and evaded humanity's attention throughout the ages, a carefully crafted message from an otherworldly intelligence? And what about the countless billions of stars that dot the infinite universe? How is it possible that we're surrounded by an infinite number of shining stars, and yet the sky remains dark? If the universe is truly eternal and infinite, and the stars are uniformly dispersed throughout the vastness of space, then in any direction we should see a star. The light from these stars, however distant, would eventually reach our planet since time immemorial. Every human inquisitive in nature has thought of these questions at least once. With the advancements and availability of state-of-the-art space tools at our disposal, we find ourselves closer than ever to unlocking the mysteries that have eluded us for ages. It's time to peel back the layers of enigma that obscure our understanding of the cosmos and cast a light upon these captivating mysteries of the universe. Take a close look at this picture. This is Eugene Cernan, seen here saluting the flag of the United States. The last person from the Apollo program to set foot on the surface of the moon. However, upon closer examination, you might notice something quite peculiar. There's not a single star to be seen in the background. In fact, every photo taken on the moon during the famous Apollo missions exhibits a sky devoid of stars, despite the fact that the universe is packed with countless sparkling celestial bodies. Even the Apollo astronauts themselves confirmed that they couldn't discern a single star in the lunar sky. This mystery has sparked all sorts of debates and conspiracy theories over the years, with some even using the absence of stars as supposed proof that the moon landed was a hoax. However, the explanation for this mystery delves far deeper than any conspiracy theory. In fact, the resolution to this cosmic puzzle once again leads us to a profound cosmic truth: the Big Bang. Why is space so black? The idea behind this query was first introduced by Johannes Kepler in 1610. Our Milky Way galaxy alone contains anywhere from 100 to 400 billion stars, and the observable universe contains roughly 100 to 200 billion galaxies. By this notion, astronomers wondered that since the universe is filled with a seemingly endless number of luminous light, emitting objects in all directions, logically every patch of sky you choose to look at should contain thousands, if not hundreds of thousands of stars. This should cause the night sky to be uniformly bright in all directions. Careful analysis suggests that the sky should be as bright as the surface of the sun. This is not the case, however, which puzzled astronomers. It is a paradox that took nearly 300 years to resolve. The paradox had emerged from the steady-state theory, which was the most widely accepted viewpoint on the universe at the time. The steady state theory said that the universe has been and always will be like it is today, and moreover, that the universe was infinite in size, had no beginning, and was uniform in all directions, and did not expand. Initial attempts to resolve this paradox involved speculating that most of the stars were simply too far away to be seen. However, this explanation was quickly dismissed as the steady state theory itself posited that the universe had existed infinitely long, thus allowing light from even the most distant stars to reach us and contribute to a bright sky. Johannes Kepler came up with a different solution to the paradox by challenging the steady state theory. Kepler suggested that the stars in the universe extended only to a finite distance, beyond which the viewer encountered only empty space. While this idea seemed plausible, of course, this solution prompted the questions: how far away is the boundary, and what lies beyond it? Additionally, the notion of a finite universe posed challenges, such as it would eventually collapse in on itself under the gravitational pull of its stars and planets. This led most astronomers to continue to assume that the universe was infinite, and thus the paradox and the steady-state theory remained as is unresolved and forgotten until after nearly 2 centuries, when Heinrich Wilhelm Ohlers, a renowned German astronomer, breathed new life into the paradox and once again asked the question, why is the night sky dark? Since then, Ohlers' name has been closely associated with the paradox. Once again, the common belief during his time was that the universe was static, infinitely old, and infinite in size. This time, ERS had a simple solution. If we assume that the universe is infinite, it is logical to deduce that the opaque bodies in it would also be infinite in number, such as dust and rock that obstruct the light from distant stars, making them appear fainter The cosmic dust gradually absorbs and blocks the light of stars as it journeys through space even today. Most people subscribe to this theory, drawing parallels between it and the way clouds obstruct the sun's light and view cosmic rocks and dust. Likewise could eclipse light from stars. However, Auber's compelling solution still does not entirely solve the problem, as any rock or dust would eventually heat up and radiate the absorbed energy. The universe would still contain the same amount of radiation. The dust merely acts as a mediator, so to speak, between the stars and the observer. Ultimately, the energy we detect on Earth would be the same. So, what's the solution to the paradox? The solution to the paradox would be revealed after a wait of another 100 years in 1929, when Edwin Hubble peered through his powerful telescope. He hoped for a universe that would be collapsing, as that would prove a finite universe, just like Kepler said. But to his shock, he discovered that the universe was not collapsing in on itself, but rather the galaxies were moving away from us, as if the space between was expanding. In fact, the further away the galaxy, the faster it was moving away. The universe appears to not be falling in on itself, not remaining static, but expanding. This raised a new question. If the universe is expanding, then what does that mean for the early universe? Cosmologists now believe that the universe was once incredibly small and dense, and that it expanded rapidly in a phenomenon known as cosmic inflation. As the universe expanded, it cooled down, and eventually stars and galaxies formed. This discovery ultimately led to the development of the Big Bang Theory as we know it today. Scientists today think this happened about 8 billion years ago. It is the most accurate model of the birth of our universe today. Most scientists think the universe has a finite age and that it started 13.8 billion years ago when we look at 13. Yep, my brain is melting a little. Billion-year-old light. It's not that we don't see stars just because the light from them hasn't gotten to us yet. We don't see any stars because we're getting a glimpse at the universe before any stars had formed. A starless universe the far we look. The farther back in time we observe until we reach the edge of the universe. This is not a physical edge, but instead the afterglow of the Big Bang, known as the cosmic microwave background, the farthest point in the universe that we can observe from Earth. When we point our telescopes past the earliest stars, we see this light. This is not starlight, but the light left over from the Big Bang, forming a background beyond the stars. But wait, the Big Bang theory seems to introduce a new problem. It states that the universe was much brighter in the past, especially at the end of the recombination era. All points of the local sky at that era were comparable in brightness to the surface of the sun due to the high temperature of the universe in that era. So the cosmic microwave background should actually be dominating our night skies back on Earth, resulting in a constant need to wear sunglasses all the time to avoid being blinded by the intense brightness of the universe. Thankfully, this is again offset by the fact that the universe is expanding, and the expansion hasn't stopped after the Big Bang. Instead, it has only gotten faster, meaning new space is constantly being created even faster than the speed of light itself at first sight. This may seem the violation of the principle of special relativity, which states that nothing can move through space faster than the speed of light. But in fact, it's not. The expansion of space is not caused by objects moving through space, but rather by the stretching of space itself. This stretching is due to the effects of dark energy, a mysterious force that is causing the expansion of the universe to accelerate the expansion of spaces, measured by a quantity known as the Hubble constant, which expresses the rate at which the universe is expanding. Currently, the best estimates of the Hubble constant suggest that space is expanding at a rate of about 73. 3 kilometers per megapark, which means that the distance between 2 points in space will double in size in about 9.8 billion years. Now, as you may know, light is a wave, and as stars move away from us, their light waves get stretched out. The human eye can only see certain wavelengths of light, and when the wavelengths get too long, we can no longer see them. This is called red shift, as red has the longest wavelength of all the visible colors for very distant objects. The light waves get stretched so much that they become infrared, and we can no longer see them. So in a sense, the night sky is lit up. We just can't see it because of our limited human eyeballs. But telescopes can, and that is why we get to see such images. So finally, this is how the solution to the paradox plays out. Because of the finite speed of light and the fact that the universe has a finite age of about 13. Yep, my brain is melting a little. Billion years, this finite age, means we can only see stars and galaxies whose light has had enough time to travel to us. The expansion of space-time complicates things even more in the far-out regions of space, where space is expanding faster than the speed of light. The light from those galaxies will never outrun the expansion. No matter what we do or how long we wait, we'll never be able to see light from those galaxies. It will never light up our skies. What we see in the night sky is just a tiny fraction of the whole cosmos. We call this the visible universe. And we cannot even, with the most powerful telescopes, see beyond this horizon. It isn't just a horizon in space, it's a horizon in time. Beyond the edge of our visible universe, the light will never outrun the expansion. Due to this expansion much further into the future, about 100 billion years from now, imagine, we invent a powerful new telescope which will allow us to explore space beyond the galaxy, but as we peek through the telescope, we find nothing but darkness and empty space. The generation of people have come to understand that they exist within a seemingly endless and almost informationless void. As the age of the cosmos approaches a 100 billion, the expansion of the universe will cause all other galaxies to vanish. Beyond the cosmic light horizon, this means that light from other galaxies will no longer be able to reach us. Put another way, galaxies will be pushed aside out of the observable universe and can thus no longer be observed today. Today we lose about 20,000 stars a second, and if you think about it, we are rather fortunate to exist at a point in time when we have access to such an abundance of information. Sure, there are a lot of things about the universe that we do not understand, but at least there's hope that one day we will. The distant future of a 100 billion CE, however, would be so information deprived that when they aim their equivalent of the Hubble telescope towards a seemingly empty region of space, the returned image would also be empty. Of course, the same is true today. We have no way of knowing what lies beyond the observable universe. But one final question remains: why are these moon pictures devoid of stars? Surely with nothing in the way, like an atmosphere, we should be able to see some stars in the background. For this, we must learn how color is actually formed. Color is a complex interplay between light and matter. Light is composed of electromagnetic waves of different wavelengths, and when it interacts with an object, some wavelengths are absorbed by the object, and others are reflected or transmitted. The colors that we see are a result of the wavelengths of light that are reflected back to our eyes. For example, if an object appears red, it is because the object has absorbed all the other colors of the visible spectrum. such as blue and green, and reflects only red light back to our eyes. Similarly, if an object appears white, it is because it reflects all the colors of the visible spectrum, while an object that appears black absorbs all the colors and reflects none back to our eyes. We are able to see blue sky on Earth because particles in the atmosphere act as mirrors. The word literally means atmos, meaning vapor, or atoms, and sphere, meaning globe. During the night, the sun sets, and there is no sky to obscure our view of the stars on the moon, however. There is no atmosphere to scatter light, but still we don't see stars. This is because the light from the sun travels in a straight line without scattering, and all the colors stay together. Looking toward the sun, we thus see a brilliant white light. This is what happened with the Apollo astronauts. Every lunar landing took place on the day side of the moon. Even though there was no atmosphere above them, the reflection of the sun's light from the moon's surface made their eyes temporarily blind. The high brightness intensity glare from the sun blinded them and their cameras' sight of the stars. Though one astronaut reported being able to see some of the brightest stars when he was in the shadow of the lunar module, looking direct up with his protective visor raised. Imagine, though, if astronauts ever landed on the night side of the moon and have their eyes adjusted to near pitch black conditions, they would get a stunning view of the stars. If the Earth had no atmosphere, then even Earth's sky would look like the moon's currently, taking into account light pollution and the limitations of the human eye we can see. Honestly, I didn't expect that. Only 3,000 stars during the night sky and only about 300 stars on a full moon night. This is why some scientists believe it would be a great idea to spend money and time building a large telescope on the night side of the moon, the enigma of the obers. Paradox remains one of the most intriguing mysteries in cosmology, and its solution has provided a deeper understanding of the nature and structure of our universe, given the millions of billions of Earth-like planets. Life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein, according to a recent comprehensive survey by Pew Research Center, 2/3 of all Americans now firmly believe that alien life does indeed exist, and at least 51% have full confidence that UFOs reported by people in the military are likely evidence of intelligent life outside Earth. And considering the significant and groundbreaking advances in astrophysics, scientists today firmly believe that there is a compellingly high probability of discovering extraterrestrial intelligence within the next few decades. Seth Shostak, a distinguished astronomer at SEI, Search for Extraterrestrial Intelligence, has boldly proclaimed that in a mere couple of decades we will unequivocally uncover tangible evidence confirming the existence of intelligent life beyond our planet as humanity casts its ever-expanding net across the vastness of the cosmos, capturing evidence of thousands of worlds. One ancient question haunts us. Is anybody out there? The vast expanse of the cosmos, with its many galaxies, stars, and planets, makes it very obvious that there is a possibility for life to exist elsewhere, even if we accept that the origin of life on Earth was a rare occurrence. The immense size of the universe serves as a large blank canvas for the diversity of life to emerge. It is a landscape that might include intelligent beings at all levels of development, ranging from the least advanced to the most evolved. Just imagine yourself alone, weightlessly floating in the vast expanse of space. The silence can be deafening, and the emptiness overwhelming at first glance. You may believe you are truly isolated, devoid of companionship. However, contemplate the intricate ecosystems thriving inside our bodies, often taken for granted, and ignored. Many microbes and tiny organisms may be living on your skin or within your digestive tract, their existence unbeknownst to you. While these organisms may not possess our level of intelligence, their presence serves as a poignant reminder that solitude can often be an illusion. Similarly, the idea that we are alone in the universe may also be a delusion unknown to us. Life throughout the universe could demonstrate a vast range of intellect that we unconsciously overlook. Intelligence is an extraordinary feature that has profoundly shaped our own existence, and its manifestation can take diverse and fascinating forms throughout the vast expanse of the universe. On distant planets, creatures may have evolved remarkable and exceptional cognitive abilities honed by unique environmental pressures and evolutionary pathways. Some civilizations may be less advanced than ours, perhaps. Comparable to the early stages of human development, they could possess basic communication skills, primitive technologies, and a limited understanding of the universe. Now, while on the other end, many advanced civilizations may have surpassed our own. These beings might possess highly evolved intelligence, capable of extraordinary feats of knowledge, technology, and interstellar travel. Their scientific achievements and cultural advancements could transcend our current comprehension, rendering them godlike. From our limited perspective, the diversity of intelligence in the universe surpasses the boundaries of our wildest imagination. The truth is, our self-proclaimed climbed progress might potentially be minuscule when viewed on a galactic scale in our quest to better understand the vastness of the universe and our place within it. Scientists and futurists have devised various scales and metrics. One such measure, the Kardashev scale, proposed by the Russian astrophysicist Nikolai Kardashev in 1964, offers a framework for categorizing civilizations based on their energy consumption and technological advancements. The scale serves as a powerful tool for categorizing and contemplating our future trajectory. As a species, the cage of scale is a four-tiered system that measures a civilization's ability to harness and utilize energy. The scale is based on the premise that a civilization's level of technological advancement is directly related to the amount of energy it can command. A Type 1 civilization, or a planetary civilization, has the ability to harness and use all the energy available on its home planet. This includes utilizing renewable energy sources such as solar, wind, and geothermal power to power their industries and meet their energy needs. They have achieved global unity and are capable of manipulating the resources of their entire planet. A Type 2 civilization, or stellar civilization, possesses the ability to harness the energy of their host star. They can construct massive structures like Dyson spheres or Dyson swarms to encase their star and capture its energy output. This civilization can tap into the vast resources of their solar system and utilize them to fuel their advanced technologies and interstellar exploration. A Type 3 civilization, or a galactic civilization, could utilize the energy resources of an entire galaxy, move planets, feed black holes with stars, and even manipulate the fabric of space-time. And a Type 4 civilization would be capable of creating a universe itself. According to this scale, we haven't yet reached Type 1 civilization status, but we're not a Type 0 civilization anymore. Human beings have a score of about 0.73 on the cage of scale. One famous theoretical physicist has estimated that if we increase energy consumption by 3% yearly, it would take 100 to 200 years to get us to Type 1 civilization. Once we achieve this status, we'll be able to utilize all. The sunlight, wind, and tides available to us, weather conditions, would be controlled by our will, and we'd be able to alter the course of earthquakes and volcanoes and make floating cities in a strikingly parallel manner, akin to the hierarchical classification of power utilization. Different civilizations exhibit distinct methods of communication, which can make it difficult for them to understand each other. Type 1 civilizations with their planetary scale, energy utilization, are likely to rely on traditional communication methods such as radio waves, electromagnetic signals, and optical communication. However, as they ascend the scale, they may harness technologies that allow for more advanced and efficient means of communication. Type 2 civilizations, for instance, may employ advanced and sophisticated forms of long-distance communication, such as gravitational wave communication or quantum entanglement-based systems. Type 3 civilizations capable of intergalactic travel may utilize methods beyond our current comprehension, such as wormholes or subspace communication bridging. These gaps is crucial for establishing meaningful and effective channels of understanding in order for different civilizations to communicate. Successfully, they would need to use a common form of communication in our early endeavors. As a Type 01 civilization, we began by sending physical messages into outer space. These messages, encapsulated in various forms, served as a means to communicate our presence and curiosity to the vast unknown as the first major initiatives to communicate with potential extraterrestrial beings. The Pioneer plaques and Voyager golden records were fixed to spacecraft sent beyond our solar system. The plaques, designed by astronomer Carl S. and his team, contained symbolic representations of humanity, including a map of our location in the galaxy and a silhouette of a human figure. Similarly, the Voyager golden record, curated by a committee led by Sean, contained a collection of sounds, images, and music showcasing the diversity of life and culture on Earth. The Voyage space probes are now 23 billion kilometers or 14 billion miles away from home, making them the farthest man-made object in existence. But while these messages symbolized our curiosity and desire for contact, they also present significant limitations in effectively establishing meaningful communication. The vastness of space poses a huge challenge when it comes to locating and encountering physical messages sent into the cosmos. Plaques and records launched into space are minuscule compared to the immense area they traverse. Space is vast and largely empty, making it highly unlikely for any extraterrestrial civilization to come across our plaques or records by chance. Additionally, physical messages such as the plaques and records are just a form of unidirectional community communication. They serve as a representation of our existence and aspirations, but they lack the ability to receive or transmit responses from potential recipients. Even if an advanced civilization were to come across these messages, the absence of a means for them to respond directly hinders the establishment of a meaningful dialogue. The unidirectional nature of physical messages limits the potential for an interactive exchange of ideas, knowledge, and cultural understanding between civilizations. Lastly, the huge differences between celestial objects means that the journey of physical messages can span hundreds or even thousands of years. In the case of the Voyager golden records, for instance, it would take eons for any potential reply to reach us. The timescales involved in interstellar communication again make it impractical for immediate or real-time exchanges, impeding the possibilities of timely interaction and mutual learning. After 60 years of sending various signals and scanning the skies, trying to detect artificial signals, we haven't been able to find anything, and we remain unheard. Nowadays, the main world institution devoted to the search for extraterrestrial intelligence is a project called SETI, an abbreviation for the Search for Extraterrestrial Intelligence. This project is based on the use of radio telescopes. Radio telescopes receive radio waves as we can't go to space aboard spacecrafts. Let that think in for a moment. Oh, find that intelligent life. What we look for are radio signals. Scientists use radio telescopes present around the globe to scan the skies for narrow-band signals that conspicuously stand out against the backdrop of cosmic noise. It allows scientists to eavesdrop on the whispers of the universe, just like tuning your FM radio to find the matching frequency of a radio station. Scientists often search for signals in the water-hole frequency range, which encompasses the hydrogen line and the hydroxy line. The idea is that these frequencies are natural choices for communication due to their proximity in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxy, which are abundant in the universe. However, a big hurdle stands in our path. It's the language barrier. Language serves as the bedrock of human communication, allowing us to convey ideas, emotions, and knowledge. But when it comes to extraterrestrial beings, the very notion of language becomes difficult to understand. How do we decipher the codes of an alien civilization? What forms of communication would they employ? These questions lie at the heart of the language barrier of SEI, a challenge that their scientists and researchers grapple with every day when attempting to decipher ancient languages. Linguists heavily rely on contexts and comparisons to other languages to understand their meaning. However, when faced with the challenge of decoding an alien language transmission, these familiar tools are absent. No context is available, and there are no similar languages to draw comparison from, and assuming aliens use a verbal language is a significant assumption, given that numerous animal species communicate without words. For instance, cuttlefish and chameleons communicate through body color languages, while ants and honeybees employ pheromones to communicate within their species, even if we understood their language as letters and words. Could we really understand what they're saying? Language for us is all based on cultures and requires a common frame of reference. If you were to say, I'm going on a hike and capturing some stunning views with my drone to a squirrel in the park, it would have no way of comprehending your statement. You would need to explain what a hike is, what capturing means, what stunning views are, what a drone is, what technology is, what flying is, what cameras are, what video recording is, and even the concept of visual appreciation, all of which are intuitive to modern humans. If such a scenario were to occur, it's highly likely that the alien civilization is far more advanced than humans, having achieved interstellar travel, and possibly even faster than light travel. Therefore, it becomes crucial for us to demonstrate that we possess at least a basic understanding of the universe in order to establish meaningful communication with the mathematics. As far as our knowledge extends, is a universal language, a language that transcends cultural and linguistic barriers by harnessing. Yep, my brain is melting a little. A power of mathematical concepts. We may unlock a means of communication with alien civilizations. Foundational concepts such as addition, subtraction, multiplication, and division are universally applicable, serving as a framework for numerical communication regardless of location in the universe. The fundamental truth remains that 2 plus 2 are 4, and the ratio of a circle's circumference to its diameter is approximately 3. 141, 592, and so on. While the specific numerical labels may differ across civilizations, the underlying concepts remain unchanged. One approach to mathematical communication with aliens is through the use of bits in digital communication. A bit is the smallest unit of information represented by a binary value of 0 or 1. By using a series of bits, we can encode and transmit messages. For instance, we can allocate a unique series of bits to each letter of the alphabet, creating a binary code that represents written communication. Thus, we could introduce the concept that 1 bit signifies the letter A, 2 bits represent the letter B, and so forth. This binary code could serve as a foundation for communication, allowing us to transmit longer written messages that could be understood by an intelligent alien civilization. Therefore, we could show the aliens our understanding of math. Though it would be a tremendous intellectual challenge humankind has ever faced, composing a message that can be understood by aliens will be extremely difficult, and conversation may almost be impossible. Extraterrestrials could be millions of years more advanced than we are. These hypothetical life forms may have long abandoned their biological bodies to exist solely within a computerized body. In this scenario, they may have relinquished their individual consciousness to merge into a global digital network of minds, giving rise to a vast collective consciousness due to this huge intelligence gap, and the absolute clueless about the possible aims of an extraterrestrial intelligence is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials. However, even if there were potential risks involved, even if another civilization can come to Earth, it's already too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There's no added danger of transmitting signals through active setting. Considering the information we now possess, it is plausible that a first contact could occur in the near future. It's also possible that some civilization has already listened to our messages but haven't responded because they like it that way. All these processes talked about are known as active SE, or messaging extraterrestrial intelligence, which involves the intentional transmission of messages or signals from Earth into space. By taking a proactive role in initiating communication, scientists hope to attract the attention of intelligent beings that may be listening or capable of receiving the transmitted signals. This shift from passive observation to active engagement reflects a growing belief that humanity should actively participate in the quest to establish contact with other civilizations. Nevertheless, how is it possible that, given the huge possibility of other civilizations, we haven't yet received any evidence of their existence? The question of great silence was first raised by legendary physicist Enrico Fermi and is famously known as the F-my paradox. Speaking to his colleagues once during lunchtime, he raised a seemingly simple question: so where is everybody? Why haven't we seen any proof of alien civilizations yet? Given how likely it is that they exist, perhaps at the end of the day, maybe they simply don't bother to communicate with us. When you consider our civilization's level of development, the answer is pretty obvious. Why would they? The logistics required for interstellar travel are only available to civilizations that have reached Type 2 at the least, and in their eyes, we're not worth it. What person in their right mind would try to communicate with ant? How would an ant be able to recognize that someone's trying to communicate with it? After all, in terms of our development and technological advancement compared to them, we are akin to highly developed ants that have taken over an entire planet. This is called the zoo hypothesis. The extraterrestrials may have chosen not to initiate contact or reveal their presence, for various reasons such as respecting our development and not interfering with our evolution, avoiding potential conflicts or cultural clashes, or simply having no interest in communicating with less advanced civilizations. Another explanation for the FMI paradox is that we may have already received those signals, but we haven't realized it, we haven't perceived the signals, or we haven't been able to understand or decode them. In this case, some strange signals from outer space have been received. Their origins are now being investigated, and they have posed serious questions for scientists. The most famous signal that has been detected came in 1977 at Ohio State University's Big Ear Radio Telescope. While listening for signals from another civilization, a strong message spread out over frequency was observed. It looked exactly like the kind of signal we would want to receive from extraterrestrial beings. During his work on the night shift on July 15, 1977, Jerry and a professor at Ohio State University and a volunteer for the SETI project observed the peculiar transcription of the radio signal made by a computer on a section of paper feed. Later, it was confirmed that this signal was the most intense anomalous signal detected up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals. It had come from the constellation of Sagittarius. The computer processed the received signals into a series of alphanumeric characters, producing the sequence 6EQUJ5. In fact, it was so astounding that when the technician looked at the printout the next morning, he wrote "wow" in the margin, and that has become known as the wow signal, which has kept the international scientific community on edge until today. And his team conducted an exhaustive examination of the signal and eventually ruled out any interference coming from Earth over the following month. The operators of the radio telescope attempted to relocate the signal, but they were unsuccessful. Astronomers have looked at the same part of the sky many times since then, hoping to find the wow signal again, but they have never been able to replicate it. The key to progress in SETI is to find a signal that is as remarkable as the wow signal, but not just once. It needs to be found repeatedly. Today, the origin of that signal is still under investigation. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe. That's why human beings and their enthusiasm for knowledge and exploration have started the search for intelligent life, with the hope of sooner or later finding it or being found by it. The first contact may not happen within our lifetimes, but whenever that occurs, it will be a turning point in the life of the human species. What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Will mankind be prepared? On November 13th, 2004, scientists at NASA were using the Hubble Space Telescope to capture images of a previously unexplored and empty region of the sky. With low and minimal expectations, they did not expect a lot in return, just a dark and empty image, and the scientists could call it a day. The telescope would return. However, an image of a planet located just 25 light years away from us, orbiting a star double the size of our sun, this was the first time a planet was directly observed through a telescope against their expectations. The scientists could not wrap their heads around what had just transpired. Never before in history had a planet been found out on the basis of direct observation. In fact, the person who discovered it said he nearly had a heart attack. The image that was captured reveals a star at the center now, formerly known as Felhot, which is surrounded by huge swirling clouds of dust and debris encircled by a continuous round asteroid belt, and among these millions of rocks dotting the image lies a planet surrounded by real mystery, once named Dagon. This planet, clearly visible in the photo, never truly existed. What you're seeing right now is nothing but the phantom of a planet that never came into being. Astronomy has not yet encountered anything like this before. What could it be? A glitch in the matrix? Could someone else be involved? Where could a whole planet disappear to in 2004? When NASA first discovered Dagon, something seemed off right from the start. It was behaving strangely, defying the odds because, according to what we knew, planets like Dagon, that are 2 to 3 times the size of Jupiter, shouldn't have been able to form around such a young star like Felhot, which is just 400 million years old. Our sun, for comparison, is about 4. Yep, my brain is melting a little. Billion years old, additionally, since its star is surrounded by a protoplanetary disk of gas, ice, and dust. The first planets to appear around it should be superheated and glow in the infrared instead of this Dagon that emits ultraviolet light. Moreover, that planet was incredibly radiant, shining with an intensity rarely observed on exoplanets. Its remarkable brightness raised numerous questions among scientists. But, for the most part, scientists just thought maybe it's the presence of an expansive ring system akin to Saturn, which could enhance its reflective properties, thus intensifying its luminosity by capturing and redirecting more sunlight. And what's more, research showed that Dagon behaved in a very strange manner, though it's unknown how much time it takes to make one trip around Felhot. According to the estimates, the speed of the planet just kept on increasing while it cruised on its 1700 E orbit around its star during those early years. It seemed obvious that Dagon was acting in a way that a legitimate planet should not. Its unusual movements and unexplained appearance never stopped puzzling the research team. However, due to various constraints and shifting priorities in the scientific community, the resources were redirected to other projects, and the tracking of Dagon unfortunately came to a halt. Nevertheless, the Hubble telescope continued capturing its images over the years. This hiatus that lasted a decade came to a stop in 2020, when NASA made the decision to delve back into their archives, and what they found left them astonished. The planet had mysteriously vanished into thin air way back in 2014, although in previous years the object was consistently registered by the Hubble Space Telescope starting in 2006. The planet started increasing in size and becoming more dim until it decided to finish the scientists off and just disappear, as if it had never existed, leaving everyone perplexed and searching for answers. It looked like the planet didn't just vanish, but dissipated. Scientists had reached an impasse. All of these events went against everything the scientists knew about exoplanets. Until now, the researchers had to practically review the Felhot data again to come to a new radical conclusion that the planet Dagon never existed, and to substitute some other object in place of Dagon. One intriguing theory that emerged regarding the disappearance of planet Dagon was the notion that it was a rogue planet that was wandering through the cosmos rather than a permanent resident of its star system. This theory suggests that Dagon was not a permanent resident of its star system, but somehow got detached from its parent star, venturing into the Fa-Halt system, captivating astronomers who clicked its presence in the nick of time, and eventually departed the Fa-Halt system. The idea of a planet on the move untethered from a star's gravitational pull added a layer of intrigue to the mystery. What cosmic forces guided Dagon on its trajectory? Did it also encounter other star systems along its path, engaging in gravitational dances that reshaped its course as scientists delved deeper into the intricate dynamics of the Fa-Halt star system? A more plausible explanation emerged. Extensive analysis of the system's gravitational interactions and the presence of a massive debris disk revealed that the likelihood of Dagon being an elusive wanderer was slim. The complex gravitational forces exerted by the stars and the constraints imposed by the surrounding debris disk would have significantly hindered the planet's ability to roam freely without being influenced or detected, and if planet Dagon had indeed been a rogue planet. Traversing the system, it would have left discernible traces of its passage in the surrounding debris disk, much like the trails formed by the wings of an airplane on clouds. Just as these trails offer evidence of the airplane's presence and movement, astronomers expected to observe distinctive disturbances or patterns within the debris disk caused by the interaction with Dagon. Yet, despite meticulous examinations, no significant indications of such disturbances have been found. The ABS absence of discernible breadcrumbs akin to the trails formed by airplane wings in clouds raises doubts about the hypothesis of Dagon as a wandering planet. Scientific scrutiny, guided by evidence-based reasoning, compelled scientists to explore alternative explanations for the vanishing of planet Dagon. A new and the most possible theory proposed by the scientists suggests that the object, originally interpreted as an exoplanet, was a slowly dissipating dust cloud that formed as a result of a massive collision between two asteroids or planet fetuses, each about 200 kilometers or 125 kilometers in size. This discovery is even more amazing because a collision between two small celestial bodies is incredibly rare. The ability of scientists to capture the image of the collision was an incredible stroke of luck in the vastness of space, where distances are unimaginably immense. Such collisions between celestial objects are estimated to occur once every 200,000 years or so. The collision must have happened back in 2004, when the Hubble telescope was surveying the A area around Fumal H. HAL coincidence number 1. As time went by, the dust began to spread, which explains the increase of the object's size and the lowering brightness coincidence number 2. And the dust cloud that formed in the collision explained the eccentric orbit coincidence number 3. And so, a string of incredible coincidences confused the astronomers and aided a beautiful legend about a strange and unpredictable planet Dagon that does not look like a planet or move like a planet, does not revolve around a host star or an elliptical orbit like a planet, and instead moves along a runaway trajectory that eventually takes it far away from the star. It was an extraordinary occurrence that they were able to witness and document this event, defying astronomical odds after connecting all the dots and examining the accumulated evidence. Scientists ultimately concluded that Dagon, once considered an exoplanet, should no longer hold that status. Currently, it's believed that planet Dagon's dust cloud, resulting from a colossal collision, must span an impressive expanse of 300 million kilometers. It must be composed of tiny dust particles measuring just 1 micrometer. In size surpassing the scale of any known planet, this massive yet tiny dust particle cloud has rendered Dagon invisible to the Hubble telescope. The disappearance of planet Dagon provides a rare opportunity to study planetary collisions unraveling. Their dynamics and aftermath computer simulations and observations have revealed that powerful space collisions can even transform celestial objects into expansive clouds of fine particles. The similarities between the DAG and collision and our solar system's early stages are also significant. By analyzing the debris and its composition, scientists gain insights into the processes that shaped our cosmic neighborhood. Billions of years ago, the scattered particles in the FMEL-HALT star system offer valuable information about the building blocks of planets and the conditions that facilitated their formation. This knowledge enhances our understanding of planetary systems and fuels our exploration for extraterrestrial worlds. But this ain't the first time an object in space vanished before scientists' eyes. A similar tale occurred with exoplanet Alpha Centauri b in 2012. Astronomers at the European Southern Observatory detected fluctuations in the radial velocity of a star using the precise HARP spectrograph. These fluctuations could only be caused by a planet's gravitational pull. This breakthrough method, known as dew spectroscopy, is highly reliable, with only a 0.1 margin of error. With just one miss among 1,000 hits, it ignited a profound sensation within the scientific community. This fervor was further heightened by the fact that Alpha Centauri b situated a mere 4. Honestly, I didn't expect that. 5 light-years away from our solar system stood as the closest exoplanet in proximity. Astronomer revealed that this planet orbited its star too closely outside the habitable zone, with surface temperatures reaching around 1200 degrees C, nearly 3 times hotter than Venus. Scholars eagerly sought to calculate its orbit parameters. But before they could do so, Alpha Centauri b vanished into thin air. 3 years after its 2015 discovery, reanalyzing the data, experts at the University of Oxford discovered that the velocity fluctuations initially seen as proof of the exoplanet's existence were in fact just calculation errors. However, it's downright bizarre when, instead of a planet, a star mysteriously vanishes after being diligently studied. For a solid 10 years, from 2001 to 20, numerous astronomical teams locked their gaze on a luminous blue variable star nestled within a dwarf galaxy called PHL 293b, situated 75 million light-years away. Their aim to learn more about how these types of stars end their lives. These luminous blue variables have a distinct and unmistakable light signature. They're colossal supergiant or hypergiant stars teetering on the precipice of their life cycles, bursting with brightness and plagued by instability. They undergo violent outbursts and eruptions that cause drastic fluctuations in both their radiance and spectral characteristics. During these dramatic episodes, their luminosity can even double in intense density. Staying true to the nature of these luminous blue variables, our mystery star, under scrutiny in its advanced life stages, shone brightly with its radiant luminosity. However, when scientists directed the powerful Very Large Telescope of the European Southern Observatory toward the PHL 293b galaxy in 2019, the star had mysteriously vanished. A meticulous analysis of data collected between 2011 and 2016 revealed an unsettling truth. It had ceased to be visible after 2011, according to astronomers Only two primary possibilities could emerge from this point. Firstly, it's plausible that the star dimmed and became veiled within a shroud of ejected material resembling the ambiguous dust cloud that may have concealed our very own Milky Way's red giant star Beetle. Just a couple of years ago, under this scenario, the star might have continued its eruptions concealed behind this thick fog of gas and dust, rendering it invisible to our eyes. Infrared observations conducted in 2009 hinted that this obscuring cloud would need to be chillingly cold to remain undetected and enshroud the star effectively, alternatively based on certain models. It is proposed that the luminous blue variable star, rather than undergoing the anticipated supernova phase, skipped this explosive spectacle altogether and transitioned into a slow spinning black hole. This notion gained support from recent research on a colossal red star that rapidly brightened before abruptly vanishing in a galaxy located 22 million light years away. Published back in 2017, the researchers hypothesized that this star had experienced a failed supernova. Before its ultimate collapse. Building on these findings, the team postulates that the luminous blue variable star in PHL 293b was also in an erupt state between 2001 and 2011, after which it vanished either by bypassing the supernova stage entirely or faltering in its attempt to initiate one in most cases. Stars nearing their end typically culminate in a spectacular supernova before transforming into either a black hole or a neutron star. This explosive phase is hard to miss, often persisting for several years. Astronomers would have undoubtedly caught a glimpse of such an explosion if it had occurred. This puzzling situation challenges our understanding of stellar life and death, forcing us to reconsider our existing models with the currently available information. The enigma of the missing star presently remains unsolved, leaving astronomers eager for future measurements across various wavelengths to unlock the secrets shrouded within this cosmic riddle. In 1972, an extraordinary spacecraft named Pioneer 10 embarked on a thrilling mission to explore the vastness of the AST belt and the colossal gas giants that dominate our solar system in the outer reaches, traveling at a speed of 32 Boskio is Uzoros Miamport, or 51,500 km. I'm Pioneer 10 soared away from Earth on a transformative journey that would eventually pave the way for future endeavors such as the Voyager probes, while the Pioneer mission ultimately achieved remarkable success. Okay, that's just wild. It was not without its fair share of challenges and obstacles. Little did the world know the probe had carried with it a hidden problem, a riddle that would puzzle even the brightest minds and astrophysicists for decades, plagued with a number of malfunctions. Pioneer 10 has sometimes been referred to as the luckiest spacecraft ever launched. Sometimes a few instances in our lives dare to challenge our basic and fundamental theories. In the early 1980s, while the probe was still in contact, scientists had noticed something quite intriguing. The probe was both slowing down and veering off course, as if an unknown force in space was putting the brakes on and tugging it back toward the sun, despite conducting extensive research and tirelessly analyzing data for about 15 years. The solution to this puzzle remained elusive. Instead, the slowdown came to an abrupt end, leaving behind one of the greatest mysteries in the history of spaceflight. Even today, the flyby anomaly continues to confound our understanding of spaceflight, causing some spacecraft to deviate ever so slightly from their intended trajectories. It remains a glitch that tests our knowledge and leaves us searching for answers launched back. In 1972, Pioneer 10 became NASA's pioneering mission to the outer planets. The probe earned its moniker from the valiant pioneers who settled the western United States because, just like those explorers of old, Pioneer 10 aimed to boldly go where no spacecraft had gone before. Pioneer 10 spacecraft achieved remarkable triumphs, marking several firsts in our space exploration. It was the first to venture beyond Mars, traverse the asteroid belt, and reach the mighty gas giant Jupiter. Pioneer 10 also made history as the first spacecraft to utilize an all-nuclear power supply and follow a trajectory that would lead it beyond the boundaries of our solar system, originally intended for a modest 21-month mission. Pioneer 10 far exceeded expectations, defying the odds and persevering for over 30 years. However, in January 2003, after its long and distant journey, the venerable probe bid its final farewell, transmitting its last signal back to Earth. Today, Pioneer 10 continues its cosmic voyage, a solitary vessel drifting like a ghost ship through the frigid expanse of space over 11 billion miles away, in the opposite direction of the sun's motion through the galaxy. Just like its twin, Pioneer 11 took off into the great unknown. A year later, in 1973, following in the footsteps of its predecessor, it became the second probe to successfully pass Mars, navigate the main asteroid belt, and reach the majestic planet Jupiter. Finally, Pioneer 11 etched its name in history by becoming the first spacecraft to fly by Saturn, unlike its twin. However, after leaving Saturn, Pioneer 11 headed out of the solar system in the opposite direction at an angle of 90 degrees to Pioneer 10, its destination, the center of the galaxy present within the constellation of Sagittarius. In 1995, NASA received the last signal from Pioneer 11, marking the end of its communication. It silently vanished into the depths of space, leaving behind a legacy of exploration, but unknown to many, both of them had left behind a puzzle that would baffle even the most seasoned physicists for decades. Just like many confusing puzzles, this one began with a subtle hint of inconsistency shortly after Pioneer 10 and 11 ventured beyond the orbits of Jupiter and Saturn. Their navigators made a surprising discovery. Both spacecraft appeared to be experiencing a greater slowdown than what the navigators had initially anticipated. It was as if an unknown force was gently tugging them backward closer to the sun, and while the scientists were aware that the probes would naturally accelerate to some extent due to the sun's gravitational pull, the data revealed an excessive slowdown that defied explanation. The deceleration experienced by the spacecraft was incredibly small, just merely 11 billionth of Earth's gravitational acceleration. In 1998, John Anderson of JPL and his colleagues calculated that the spacecraft had a deceleration rate of about 300 in per day. While this may seem like a very small difference in measured acceleration compared to the predicted values, it had significant implications. The pioneers ended up staying thousands of kilometers closer to Earth each year than originally intended. They fell short of their expected location by a distance roughly equivalent to the distance between the Earth and the Moon year. After year, the spacecraft found themselves deviating by a few thousand kilometers from their expected positions. Initially, it hadn't raised many concerns, but now it was a different story altogether. And the puzzling part was that this tiny deceleration persisted as the spacecraft traveled deeper into space. There were also two other spacecraft that encountered trajectory issues. One was Galileo, launched in 1989 to study Jupiter and its moons. The other was the ULSS spacecraft, launched in 1990 to explore the Sun. Both of these missions faced trajectory anomalies that left scientists scratching their heads. Scientists exhaustively explored various possibilities to explain these decelerations. They considered everything from gas leaks to the expansion of the universe. However, despite their efforts, no conclusive answer was found due to the lack of explanation for the slowdowns. The team hypothesized that it could be attributed to some new physics that contradicted Einstein's general theory of relativity. This even raised the tantalizing possibility of undiscovered phenomena that could reshape our understanding of the universe. In 2004, Slava Tershi, a physicist at NASA Jet Propulsion Laboratory, had a thought brewing in his mind. He contemplated building a brand new probe to investigate the Pioneer anomaly. To get to the bottom of it, this new probe, however, unfortunately, never took flight beyond the confines of the drawing board. Slava had to work with the data that was available, and he didn't have any fresh data to work with since. What the heck were they thinking back then? Spacecraft had stopped communicating with Earth, but that didn't deter Slava, though he faced a couple of more challenges along the way. Firstly, those Pioneer spacecraft were designed back in the day when computer AED design wasn't in the picture. It was all good old-fashioned paper and pencil. So he had to start from scratch and create 3D models himself. Secondly, NASA didn't require achieving mission records, making it quite a task to locate the data. Despite these setbacks, Slava and his team searched through old Pioneer communications and data, unearthing digitized files from JPL navigators and seeking additional information from various NASA centers. They discovered boxes of magnetic tapes at NASA's Jet Propulsion Laboratory and magnetic optical tapes at NASA's ACES Research Center. A programmer named Victor Toth from Canada joined forces with Slava and helped create a program to read and structure the data. In the end, Slava and his team collected over 43 gigabytes of information. That doesn't sound like much by today's standards, but back in the 1970s, it was an incredible trove of data. So what did he find? The answer to the anomaly resided in the structure of the probe itself. You see, NASA engineers had to spin the Pioneer probes to maintain stability and ensure they remained pointed towards Earth. This was necessary because the antenna needed to be directed towards Earth to exchange data. On the other hand, the Voyager missions had a more advanced technology that used thrusters to maintain. Yep, my brain is melting a little. Spacecraft stability, however, what was causing the deceleration? It was discovered that the deceleration was due to thermal radiation emitted by the spacecraft. There were two sources of thermal radiation positioned on the leading side of the spacecraft. The first source was the electric box, and the second was the radioactive material responsible for power generation. Both of these sources emitted heat in the direction of the spacecraft's motion through space. This emission of heat created a small photon pressure in the opposite direction of the spacecraft's motion, resulting in the observed deceleration. It's the same principle that operates in a solar sail, where the spacecraft is propelled forward as photons from the sun collide with it. Now here's the interesting part. The slowdown of the Pioneer's probes came to a sudden halt when the radioactive material was completely used up with the wealth of new data at their disposal. Slava and his Colleagues were able to calculate the amount of heat generated by the electrical subsystems and the decay of plutonium in the Pioneer power sources. These calculations perfectly match the anomalous acceleration observed on both Pioneers, but other spacecraft like Galileo and Rosetta took into account the thermal recoil, yet they still encountered deviations in their paths. When the Galileo spacecraft was on its way to Jupiter, something peculiar happened during a gravity assist maneuver, where it flew past Earth. Scientists noticed an unexpected increase in the spacecraft's speed. There was a discrepancy, a difference in speed relative to Earth, with an unanticipated boost of about 4 mmHz. This effect, known as the flyby anomaly, has affected almost every spacecraft out there. The flyby anomaly reveals something quite intriguing. Some spacecraft actually gain more speed when traveling to or away from Earth than what scientists initially predicted, and so far, no convincing explanation has been found. The flyby anomaly made another appearance during the near-Shoemaker incident in 1998. This mission had its sights set on studying the asteroid 433 Aros. To reach its target, the near-Shoemaker spacecraft performed a flyby of Earth. And guess what? Scientists observed an even larger deviation in the spacecraft's velocity compared to the Galileo flyby. This time, the speed unexpectedly increased by around 13 mmHg because the recurring nature of this phenomenon in these two cases piqued the interest of the scientific community. They started delving deeper, reviewing data from other flybys as they dug into the records. More cases emerged: the Messenger spacecraft's flyby of Earth in 2005 and the Rosetta spacecraft flybys in 2005 and 2007 all revealed similar anomalies in their velocities. This was no longer just an isolated incident or a measurement error. The flyby anomaly had accumulated enough evidence to demand serious attention. Numerous theories have been put forward to explain the flyby anomaly, ranging from the mundane to the extraordinary. One hypothesis focuses on the shape and composition of our planet. You see, the Earth isn't a perfect sphere. It's more like a spheroid due to its rapid rotation. It has varying densities and features like mountains, oceans, and ice caps. As spacecraft fly past Earth, they might expect different gravitational forces depending on the specific features they encounter. The challenge with this theory is that there are countless spacecraft orbiting Earth all the time, and if this explanation were correct, we would expect them all to experience the flyby anomaly. So there must be more to the puzzle. Another proposal suggests that the configuration of the Moon or other planets in the solar system during a flyby, along with the positions of the ocean and tidal conditions, could be contributing factors. Even though the Earth's atmosphere is thin at the altitude it flies, it's possible that even the minuscule number of atmospheric particles encountered could affect the spacecraft's trajectory. Some researchers believe that the Sun might play a role in the anomaly. It's possible that the spacecraft experiences varying levels of solar winds during each flyby. Some scientists propose that relativistic effects could be at play. The rotation of the Earth, for instance, might create distortions in the surrounding space-time, ultimately altering the spacecraft's trajectory. As you can see, the flyby anomaly is a complex puzzle, and the search for an explanation continues. Scientists are diligently exploring these various theories, conducting experiments, and analyzing data to unlock the secrets behind this intriguing phenomenon. To delve into the predictions of Einstein's theory of relativity, scientists are proposing the launch of an existing new spacecraft named STEP, which stands for Satellite Test of the Equivalence Principle. This mission was selected by the European Space Agency back in 2012, and if it gets the final green light, it will be sent into space by 2024. STEP's sole purpose would be to study gravity, aiming to achieve the most sensitive measurements of gravity ever made. This remarkable spacecraft would orbit the Earth, equipped with an incredibly precise clock on board. Shielded from radiation in a vast expanse of the universe, it would have the freedom to observe and analyze gravity with its exceptional sensitivity. It could detect both the gravitational forces exerted by the Earth and the Sun to an astonishing accuracy of 10 to the 7th power. The spacecraft would follow an orbit that takes it through the various distances at which anomalies were observed during flybys. If gravity is indeed the cause of these anomalies, STEP should be able to precisely demonstrate how the magnitude of the effect changes with distance from Earth. Thus, while STEP's primary focus is on advancing our understanding of gravity, it also holds the potential to finally unlock the secrets of the flyby anomaly throughout human history. We've built an incredible body of knowledge about the universe around us. However, we're only at the beginning of this journey. The universe, a twilight realm of enigmatic secrets, remains, replete with unexplained mysteries and paradoxes shaped by unseen forces. It's like a giant jigsaw puzzle made up of an infinite number of pieces, but we can only see a small part of it and can only guess the rest in the vastness of the cosmos. Many more countless mysteries await our curious minds. There are still many secrets yet to be discovered, enticing us to unravel the mysteries of the universe. 70% of our universe is made up of something so weird and so strange, it continues to baffle the world's brightest minds. We are absolutely still lacking great ideas. It is crying out for some new breakthrough, new thinking. Perhaps the greatest remaining mystery in our universe. Dark energy is basically our name for that thing that we don't understand. It's not the color dark, it's just an expression of our ignorance as to what is this stuff. A genius could come up with a new theory. Yeah, it is quite possible. I'm kind of hoping it's me. So this is clearly a huge deal in physics and raises many, many questions. The obvious one to start with is, now, ever since the Big Bang, our universe has been expanding with space itself, stretching, moving galaxies further apart. Now, physicists used to think that the energy that was made in the Big Bang to power that expansion would eventually start to run out, and the expansion would start to slow down. Let that think in for a moment. Then, a Nobel Prize-winning discovery turned all of that on its head. Saul Perlmutter and his team measured the way the universe was expanding by comparing the brightness of supernovae. This is when a star runs out of fuel at the end of its life. They brighten as a fireworks and fade away, and they reach the same brightness. And you can then use that as an indicator of how far away it is by just looking to see how bright it appears to you. Just like when you watch a car recede into the distance, you can tell how far away it is by how faint the taillights look. If you can use the brightness of the supernova to tell you how far away it is, that's really telling you how long ago the explosion occurred, because you know how long it takes for light to travel that great distance. And what they discovered definitely shook the physics world. Suddenly he was saying that we lived in a universe that was accelerating. I remember being just incredible. I mean, all the astronomers walking around scratching their heads saying, this can't be right. Surely it can't be right. Now, exciting as this finding was, like many things in science, it raised a lot more questions than answers. Once you know that the universe is actually speeding up, then you're faced with the question of, well, what could make it speed up? This mysterious thing that was causing this newly spotted phenomena, that no one could explain was immediately called dark energy. Now, it's great to have a name for this, but it doesn't exactly explain what is driving this accelerated expansion. Now, just like with dark matter, which makes up 25% of the universe and is also currently unexplained, this weird type of energy seems to defy our laws of physics and has properties that our current models just cannot explain. So you can think of it as you get more space, you actually get more dark energy, which is like getting something for nothing, which is clearly ridiculous. The way we think about it is that it's either some new stuff in the universe, some particle, or even just a new field that you put into the universe to explain the properties of the universe. So what is it that's changing the way our universe evolves? Well, scientists differ in their thoughts of what it could be from a liquid or a brand new particle, like dark matter, or even an unknown force. Now, scientists at Berkeley in California are looking for something that they call chameleon particles. This is a whole new type of particle that's thought to create a force which, when it interacts with other particles, changes those particles' mass. By putting atoms in a vacuum, they're hoping to expose these chameleons. The experiment works by first collecting a cloud of cesium atoms on top of the spheres, and the atoms are free to fall, subject only to the Earth's gravity and the potential chameleon force. We will either discover the particle or rule it out once and for all. So far, they haven't found any evidence for these chameleon particles and their elusive force, but it is an idea that continues to be explored. So whatever this energy is, we now know that it makes up a whopping 70% of our universe. Now, the obvious place to start is by looking at how the universe formed and has evolved with incredibly powerful telescopes. One of the things that I do is try to simulate the entire universe and tie what we think about the physics of the evolving universe to what we actually see with surveys like DCDZ, the Dark Energy Spectroscopic Instrumentus. One of these incredibly powerful telescopes, observing the distant universe, and the further away galaxies are, the younger they appear to us. That's because light takes time to travel to us. It can take even 1 billion years to reach us here on Earth. Thanks to this, we can look at the average distance between galaxies at different cosmic times and look how it's changed due to the expansion of the universe, and therefore figure out what is the role of dark energy, what we need to do that is more detail, and we get more detail from more data. Now, there's a lot of projects and telescopes that are mapping the universe in this way, but one that we're all very excited for is the launch of the space telescope Euclid. In 2022, it's the most powerful telescope ever created, even dwarfing the iconic Hubble Space Telescope. So it could be just what we need to solve this problem. Honestly, I didn't expect that. These are going to be the biggest images that come down from orbit. You have an image effectively of 625 megapixels. So that's about roughly 300 HD television screens full of data, and that comes down every 10 minutes. This imager takes roughly the same amount of data that Hubble has taken and will take in its entire lifetime in one day. The hope with Euclid is that it will be able to give us the detail that we so desperately need to be able to solve this problem. We have lots of theories and hundreds of models that could still fit our data. When Euclid comes, lots of these can be thrown away, and I could narrow down the possibilities of what this dark energy is. Euclid will give us a coherent data set that we can test all these theories against. So dark energy remains the biggest mystery in physics. But with all these great scientific minds across the world and all the projects focused so desperately on figuring out what this is, It might not be long before we finally find this huge missing piece of the puzzle. We need teams like Euclid. That's the only way you can get the data that you need. But to understand that data, to give it some interpretation, to give it an idea, could come from one person. That could be the next Einstein. The strongest magnet in the universe has been discovered. It's an exotic, ultra-rare neutron star. It's called GRO, J1000A257. And it's got a magnetic field over 1 trillion times stronger than the Earth's. Stars like this are so strong that they have the power to do ridiculous things to anything that comes even remotely close. If you got within 1,000 kilometers of it, you'd simply dissolve. Your atoms would be super stretched. Their shape would warp into something completely unrecognizable. The molecular structure that makes you up? Forget about it, it's gone. You'd just disappear. So nothing good can come from messing with a star like this. But how magnetic is it? Well, its field is calculated to be 1 billion Tesla. Tesla is the unit we use to measure how magnetic something is. Just to put this into context, the Earth's magnetic field is 1/1,000,000th of a Tesla. But we've cooked up something far stronger in the lab. This is what 1200 Tesla did. Despite its supercharged magnetic strength, the star is actually incredibly small. It has a diameter of 20 kilometers. You might be wondering just what makes a star like this so magnetic. First, we need to find out more about how these neutron stars and their rarer subtypes come about. Neutron stars are created by the death of massive stars. Having run out of fuel, their upper layers are obliterated and the core collapses. We witness an extreme explosion, a supernova. Leftover electrons and protons come together to form neutrons, and with the right solar mass, we end up with a neutron star, a severely squashed down version of what was there before. Astronomically speaking, they're the densest thing out there. What the heck were they thinking back then? If you dropped a marshmallow onto a neutron star, it would have the energy of an atomic bomb because the gravity is so powerful. So they're cosmically very small, but unbelievably dense. Let's put it another way. If I had a matchbox full of neutron star material, it would weigh approximately 3 billion tons. Or let's go another way, maybe something smaller, like a sugar cube. A sugar cube of neutron star stuff would weigh as much as a mountain, and I'd be very strong. But what stuff makes up neutron stars? Why are they so dense? Well, their insides are a bit of a mystery. We know that they have atmospheres made up of hydrogen and helium, and an outer and inner core made from neutrons, electrons, and atomic nuclei. But we still don't know what hyperdense matter lies at their center. So does this density cause a star's megamagnetism? Actually, we don't know. This takes us literally to the edge of scientific thinking. Scientists believe that as a neutron star is born, the magnetic field of the previous star shrinks. Combine this with this unusual, highly dense matter, and this could cause the phenomenal magnetism it wields. So we don't really know why a neutron star is so magnetic. It's a total mystery. But the neutron star's density is just the tip of the iceberg. They are capable of far stranger things. We observe binary systems of 2 neutron stars that are in orbit around each other. Can you believe this actually happened? And when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. So when 2 neutron stars fuse together, colliding violently, this can create black holes. But this can also give birth to things called magnetars. And that's what is believed to have happened with our strongest magnet. However, there's another reason it's one of the rarest stars in existence. Not only was it once a magnetar, it's now what's known as an X-ray pulsar. This pulsar is truly incredible. It exists in a binary system with another star orbiting each other, but it's not an equal relationship. The highly magnetic pulsar feeds off its lower density companion with energy accumulating at its magnetic poles. It gives off bursts of X-ray pulses, like a lighthouse in the deep dark corner of the universe. Dame Jocelyn Bell Burnell discovered them in 1967 and wrote the rulebook for how we monitor these phenomena. The pulses are short and quite steep, so these things have to be small. The other thing that we very quickly established was that the post period was very, very constant. It wasn't getting tired, which means it's got large reserves of energy, which means it's big. So it's small, but it's big. So you have to be more precise in what you're saying. It's small in width, it's big in mass, so high density. That's the first pulsar. CP 1919. So that's what it sounds like if you listen to the radio signal. So that's the whole star spinning at that rate. And there are some that are even faster. You listen to the fastest one, it would sound like your kitchen blender. It's going at 700 revs per second. But we still don't know so many things about stars like the strongest magnet in the universe. Crucial elements of the mystery remain unsolved. Why are these stars so magnetic? And what is hidden deep in their core? Maybe one day the star's secrets will be revealed. We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar, to here but still different. Multiple universes now are a genuine possibility, which begs the question. Now, it probably doesn't surprise you that studying parallel universes was once considered completely bonkers in the scientific world, and even alienated people who decided to pursue it. When I was a grad student, I used to secretly print out my multiverse-related papers. This job was the only job I was ever interviewed for. I was on the verge of having to drive a taxi cab. Now, theoretical physicists have realized that parallel universes are possible mathematically, at least. Now, one of these reasons comes from the weird world of quantum physics. The important thing to remember about quantum mechanics is it's weird. It really is weird. It's the study of subatomic particles, the building blocks for every single thing around us in the universe. And what it tells us is that these particles can be both particles and waves, but crucially, they can be both at the same time, which splits our reality, giving us multiple different universes. The idea here is that when you make a measurement of a particle that's here and there at the same time, and you find the particle over here, then there's a you, which finds a particle over here in this world. But at the same time, there's another world over there, where another you has found the particle over there, and both of these worlds are equally real. So the quantum multiverse is not separated from us by distance. It's not someplace very, very far away. It's someplace effectively here in space. But the complexity of the quantum dynamics prevents these different branches from talking to each other. Whether you like it or not, the fact that we live in a multiverse is the dominant scientific paradigm. Suck it up. Another theory is one of mathematical inevitability. If our universe is made from a finite amount of simple matter, then it follows that other universes are made in a very similar way. Just as this house is made out of fundamental building blocks that we call Legos, everything in our world is made off fundamental building blocks we call elementary particles. And if you have some random process arranging elementary building blocks in a finite volume, there are, of course, very, very many different ways in which it could do this. And that means that if this process repeats and an infinite number of other volumes of the same size, then we're guaranteed that eventually it's going to create every possible arrangement. We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar to here but still different. Even a Max over there who's identical to me, not just in his physical appearance, but in that he actually feels that he is me. Another theory called inflation describes how the universe expanded exponentially in the very first tiny fraction of a second after the Big Bang. But with some areas of space expanding faster than others, creating bubbles or pockets of space-time, where other universes could have formed. If this idea turns out to be right, then it could mean these pocket universes developed with the very own laws of physics, so there could be another you in those universes that's able to walk through walls or fly through space. So if our universe is not alone, the question remains. According to quantum theory, there's a new version of you and a brand new universe made with every single decision you make. So every time I flip a coin, say heads or tails, that is just some little quantum accident? Okay, that's just wild. The universe is splitting into two worlds every time it comes up, heads or tails. So our experience of the splitting is like the experience of walking through a garden of paths that fork. When we come to a fork in the path, we take one or the other heads or tails. But both forks exist at the same time. We only experience one of them. There are literally gazillions of universes out there, of which ours is only one. Then there's the patchwork model and near-identical copy of our own universe, just made elsewhere. In this kind of parallel universe, there's another you that's very similar, just with subtle differences. We're guaranteed to find countless variations, where things are similar to here, but still different. The dinosaur-killing asteroid that was our lucky break missed Earth, so there are no humans, just dinosaurs in Winchester today. There's another one where I didn't make it as a physicist, but I'm actually enjoying life working as a bartender. Then there's a whole bunch which are very similar, where I just chose to dress a little bit differently. These ideas all point towards multiple weird and wonderful universes existing out there. But with scientists not able to see the entirety of our own universe, scientists think that they might be getting a little bit closer. Truth goes through 3 stages. First, it's ridiculed, then opposed strongly, and finally becomes self-evident. Perhaps now we are reaching the stage of self-evident. Scientist Laura Mersini Houghton found something really weird. She found evidence for what appeared to be 2 universes crossing over. The detection of the cold spot, which was one of the signatures that we predicted by tracing forward the quantum entanglement of our universe with all the other surviving universes. We predicted that there should be a large area in the sky of about 10 degrees, and indeed that's what was observed about 7 months after we made the prediction. Recently, there's also been a big leap forward for inflation theory, which predicted that if this rapid expansion of the universe happened, it would send ripples out into the universe. We call these ripples gravitational waves. We'd never detected anything like this until 2015, when 2 experiments called LIGO and Virgo managed to detect gravitational waves coming from the merger of 2 black holes. With that detection made, it makes it more likely that we might be able to detect gravitational waves from inflation. But why should we really even care about figuring out if multiple universes exist? Well, it actually feeds into the age-old question of what is our universe expanding into. If other multiple universes exist, perhaps our universe expands as neighboring ones contract, and this could actually tell us more about our own universe and especially how our own universe will end. Perhaps eventually we will expand until those other neighboring universes also then have a big bang and start expanding into us, which means that we then start contracting, and perhaps our universe will end in Big Bang, but in a big crunch. The Earth is speeding up. It's literally spinning faster. Could it cause a tech meltdown? And what have melting glaciers got to do with it? You may or may not know, I wouldn't expect you to know, there are 86/162 seconds in a day. But scientists who measure time have found that in 2021, the average day is 0.05 moments less than this. That's because the Earth is literally speeding up. Okay, so you might think 0.3 so what? But this actually goes against everything that we expect to see happen, and scientists are desperately trying to find an answer. Because since its creation, Earth's spin has actually been getting slower. In a not very recent history, the days on Earth used to be twice as fast. But what does a faster spinning Earth actually mean? 3.5 billion years ago, the planet's rotation used to be only 12 hours long. At that kind of pace, life would really suck. We'd have nightmarish weather patterns with hurricanes tearing across the land. Centrifugal force would pull water towards the equator, flooding entire regions like Indonesia and the northern tip of South America. Okay, that's a worst-case scenario, and Earth is unlikely to ever spin that fast again. But if we keep speeding up, it could be bad in another way. By 2030, there could be a full-scale technological meltdown. GPS relies on precision timing, and if a day falls too far behind that 24-hour benchmark, there could be disastrous consequences. For one, satellites could lose their correct place in the atmosphere, and we'd lose all means of being able to predict where they are in the sky. If we leave this slip for too long without correcting it, then our navigation systems will be completely wrong, throwing all of our smart technology off course. Fortunately for us, we can sidestep this disaster, and there's a fairly easy workaround. Timekeepers can add and take away what's known as leap seconds to account for these tiny differences. They can alter what's known as International Atomic Time, which can be adjusted for the subtle discrepancies between the Earth's rotation and our clocks. And what's pretty mind-blowing is that by observing the night sky, we can keep track of these tiny changes. So keeping time is a pretty skilled art form. That's how we know that the Earth is spinning faster. But that doesn't explain why, despite billions of years of slowing down, the Earth's rotation is speeding up. So what's causing it? This is Dr. Jazz Hill Valor. She's an expert in how the climate affects the Earth's rotation. So we probably all know that the melting ice caps is going to cause sea levels to rise. Well, it's also causing the Earth to spin faster. And what happens when the Earth spins faster is that we get a greater centrifugal force. Imagine a figure skater. When you watch figure skaters, they start off spinning really slow with their arms out, and as they bring their arms in, they start to turn faster and faster. That's because they're bringing more mass towards the center of their rotation. So how can that happen on the Earth? Well, water has this crazy property where when it freezes, it actually expands. So if you think about all of the glaciers and the mountains and the ice sheets as being these huge, tall, towering sheets of ice, well, what would happen if we suddenly melted them really quickly? Which is something that we're seeing happening at the moment. If we take all of that mass in, those glaciers and those ice sheets, and suddenly it melts and gets closer and closer to the surface. Just like the figure skater bringing their arms in, all of that mass is going towards the center of rotation, meaning that the Earth is going to start spinning faster. This meltwater currently sits at the poles. This is why right now, scientists believe the Earth is spinning faster than usual. So will it get faster forever? Here's the conundrum. Actually, scientists expect this to be just a blip. Although it's been getting faster for the last 2 years, experts expect the Earth to go back to its longer-term pattern of slowing down, and it's the Moon that's causing this. This is to do with the tidal relationship between the Moon and the Earth. We only see one face of the Moon. It's tidally locked with the Earth. So as the Earth is turning, the Moon is pulling the ocean towards it. And then as we move away, the oceans go back round, and that causes our tides. So this kind of wobbly dance between the Moon and the Earth means that the Moon is slowing down the Earth, and all that energy that's lost from the Earth slowing in its rotation is getting put into the Moon's orbit. And the Moon is actually moving further away. As it continues to drift away, the effect of the Moon's gravity on Earth weakens, causing us in the longer term to slow down. What's more, over time, the melted water in the polar regions could actually make the Earth spin slower. Some scientists believe that the water will drift towards the equator, which will further slow down the Earth's rotation. This is called equatorial bulging. Think of it as a big spare tire around the middle of the Earth. It exists already down to the centrifugal force exerted on the ocean by Earth's rotation. But adding to the weight of this tire is no good thing. All of that excess water is going to go and sit around the equator, which means that there's more mass further out from the center of rotation. The equatorial bulge of water is going to get higher, which means that around the equator, there's going to be even higher sea levels than we originally predicted. It could mean that hurricanes and typhoons and cyclones that form at the equator could become more severe because there's more water vapor there. So the increased severity of these storms because of the Earth spinning faster is probably only going to be a temporary effect. But that doesn't mean we shouldn't be worried about it, because more severe storms means that we're going to see more severe natural disasters happening all over the planet. So although at first glance it doesn't seem that important that the Earth is spinning a bit faster, it really does matter, because it could be a big hint as to what else the climate crisis has in store. The northern lights on Jupiter are the most spectacular in our solar system. They're stunning, and they're bigger than our entire planet. They produce incredibly powerful flares that reach terawatts of power. That's more energy than you'd need to briefly supply all of human civilization. What causes them? Why do they seem to pulse like clockwork? To truly unlock Jupiter's mysteries, we needed a way to get closer to it than ever before. Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. We had to build an armored tank to go there. Juno arrived in Jupiter's orbit in 2016. As it got closer, the auroras on Jupiter became so dramatic and active that astronomers said it was like Jupiter was putting on a fireworks display for Juno's arrival. Honestly, I didn't expect that, which seems apt given the sheer scale of the spacecraft. Behind me is the Juno spacecraft. Basically life-size, it's an enormous spacecraft close to 70 feet in diameter as it spins around and cartwheels through space. This is one of the largest spacecraft ever made. Juno showed us more than we'd ever seen of Jupiter's auroras as they rippled over the planet's poles. The northern lights on Earth are caused by solar winds entering our atmosphere and interacting with the planet's magnetic field. Jupiter's magnetic field, also known as the magnetosphere, is 20,000 times stronger than the one here on Earth. It extends all the way back to Saturn and perhaps further, and it's the biggest structure in the solar system next to the Sun's magnetosphere. That's one of the reasons Jupiter's auroras are so huge. These gigantic magnetic tentacles capture particles from across the solar system, thrusting them towards the planet's poles, creating this epic light show that never dies. But this is only part of the story. As well as photographing Jupiter's dazzling displays, Juno also began mapping Jupiter's core. And that's when things got interesting. Jupiter is a gas giant. It is full of loads of gas, especially hydrogen and helium. And when hydrogen is under extreme pressure, it acts in a really weird way. It becomes liquid metal. Liquid metal, like at the core of Jupiter, is an ocean of liquid metallic hydrogen. And using some of Juno's findings, physicists in California tried to recreate this extraordinary phenomenon bubbling away deep inside Jupiter's core. So basically, we are creating a little planet interior inside our laboratory. Marius Millot and his team at the National Ignition Facility conducted a pretty crazy experiment. They fired lasers at a tiny target which imitates the core of Jupiter. The lasers simulate the unfathomable pressures going on inside. So this is the target that we put inside this target chamber. We fill a little portion inside this cone here with liquid hydrogen, about 20 millionth of a gram, and then we shine 80 laser beams from the top and 80 laser beams from the bottom. So the power that we put in the lasers when we shine the laser onto the target is about 500 times the power that is used for the entire United States at a given moment. T minus 5, 4, 3, 2, 1, shot. Through the laser blast, the team observed this surreal change that takes place in the core of Jupiter. At this time, the pressure got so high that the light is now reflecting off the shiny surface of the hydrogen. Hydrogen transforms from being transparent to opaque and then becomes a metal, like a shiny metal. If we were to go deep inside Jupiter, we would see a deep ocean of fluid, shiny metal. And just like that, the planet completely messed with what's possible with the elements. It throws out the rule book. On Jupiter, this metallic hydrogen makes up to potentially 50% of the planet's mass, and it's this huge liquid metal ocean that accounts for Jupiter's gigantic magnetic field. But that's not all. It also causes charged particles to leak out at its extremities, and it's this that causes the breathtaking auroras that outshine all the others in the solar system. So Jupiter's core is the main source of the auroras, but its moons also wanted to get in on the act, particularly one of the strangest moons in the solar system, Io. This moon is the most volcanically active in the solar system. Its spectacular volcanoes spew plumes up to 300 miles into the atmosphere, adding extra fuel to Jupiter's light show. So we see Jupiter in the middle, but around Jupiter, we see the moons, Io, Europa, Ganymede, Callisto. The gases that come from Io become trapped in the magnetic field, and they become accelerated to very high energies. These trapped charged particles get dragged towards Jupiter's poles by its all-encompassing magnetosphere. Energetic charged particles come in, bombard the atmosphere, make it glow, and then we're seeing this glow in the atmosphere of Jupiter. So the combination of the gigantic magnetosphere, its supercharged liquid metal core, and unique moons create these breathtaking aurorae. But astrophysicists were still puzzled by one thing. Why do these aurora light up and flash in semi-regular patterns, pulsing in this extremely bizarre way? It took a team at UCL to crack the case. In the time they watched the auroras, they found that they pulsed every 27 minutes. By closely analyzing the data sent back from Juno and the European Space Agency telescope XMM Newton, they came to the conclusion that periodic vibrations crashed across the magnetosphere, causing waves of plasma to send heavy ion particles surfing across the magnetic field toward Jupiter. But the mystery isn't over. Just what causes these vibrations? What determines the pattern of these pulses? And why does Jupiter randomly decide on these rhythmic, regular intervals? This is just the beginning of our learning about Jupiter's auroras. And that's just the start of a wider search. There were more like them across the galaxy waiting to be explored. Nearly everything we've sent into space is still there circling our planet. Huge amounts of abandoned old machinery just littering. Space, it really is a terrifying thought. When you're going 17,000 miles an hour, it does not take a big piece of debris to ruin your day. The energy would be more like a 50 caliber Browning machine gun sniper round. Experts are now beginning to ask, over the last several years, orbits around Earth have become littered with satellites and old pieces of machinery. Space junk is all the stuff that we've launched into orbit that no longer serves a useful purpose. Now, that's something to think about before bed. So it's satellites, it's rocket bodies, it's old gloves, basically litter that we have left in space. Now, this isn't a trivial issue because as we enter into a period of more rapid space expansion, from space tourism to companies putting more smaller satellites into space, it's now estimated that the number of pieces of space junk up there is over 130 million pieces that are orbiting the Earth, and that number is only growing. So space is being littered with these dangerous, uncrewed pieces of machinery flying through space at breakneck speeds. It's a lethal accident waiting to happen. In 2009, NASA actually had to order an emergency evacuation of the International Space Station when they discovered a piece of space junk about the same size as a CD traveling towards them at 8 kilometers a second. We got a call that we were having a red conjunction. We're looking around what the hecky's a red conjunction now, because we hadn't really trained for it. It was a little bit chaotic because this was the first time we had had one of these. It's either going to hit or it's not going to hit. And so worrying about it doesn't help you. All you have to do is just prepare everything that you need to prepare, so that if it hits, then you're in the best possible configuration. Now, thankfully, the ISS wasn't hit that time, but this is a genuine concern for NASA, ESA, and other space agencies, because if it was hit, the damage would be catastrophic. It gets hit by something relatively small, penetrates, but because the pressure inside it just forces the modules to open up, just like a balloon bursting. And that happens extremely quickly, and with no chance an astronaut in that module could ever get out. In fact, you can recreate these kind of collisions in a lab, and it really reveals how dangerous they really are. You see your screen flash up, and it's over. All that work is turned into this. So this piece of modern art here, if you can see, it's all splayed out. Now, that's about 250 milligrams, so that's a little bit heavier than an ibuprofen pill. And the energy that would have on orbit at, say, 14 kilometers per second would be, well, the momentum would be about the same as a hot-loaded 357 Magnum. So that's a lot of momentum, and the energy would be more like a 50 caliber Browning machine gun sniper round. A single one of these collisions can create thousands of these tiny lethal fragments that act like space bullets that ripple out into space, causing unimaginable damage as they go. In fact, some forecasts suggest that a major collision like this could happen once every 5 years. And we see thousands and thousands of near misses every single day as a result of all the junk that we put up there you end up in the situation where, it's basically a lottery in terms of whether or not your satellite is going to be hit. And this wouldn't just cause issues up in space, with so much of our modern world dependent on satellites for things like navigation and the internet, communications, weather forecasting. It would cause absolute havoc down here on Earth as well. Now, with more and more of these objects being blasted into space every single year, it's becoming a serious threat to modern life. So, what can we do about it? Step one, it's actually tracking all of this space junk, and that's something that the U.S. Air Force has been doing for decades. Pre-pass SVN 26. No time-critical commanding, no satellite conjunctions, good on step 6. They've been cataloging space junk since the early 80s. They started with 6,000 and had grown to 10,000 over the next 2 decades. And since 2009, the amount of trackable space junk has gone up by 20% to over 25,000 pieces. But the problem is, the only space junk that's trackable is stuff larger than a cricket ball, and it misses those tiny, tiny fragments that can be incredibly lethal. So space agencies across the globe are working around the clock to come up with solutions to remove this space junk. One option, to use a space harpoon. This system will capture those items of debris, tow them out of the orbits where they might collide with active satellites, and allow them to burn up safely in the atmosphere. So the idea is to have a system which takes them away from where they cause a problem and basically destroy them safely. It's a great idea. But the thing is, it's a bit of a slow tactic, because you have to remove everything piece by piece. And the problem is, we're putting even more space junk up there just to do this. Other plans include capturing them in a net ore, sticking a magnetic thruster onto them, or even using solar radiation to sail them off into the sunset. It just shows, though, with so many of these ideas being developed, how dangerous of an issue this actually is. And if our quest to remove this junk fails, and with the increase in objects littering space every single day, the question is, I want my kids and my kids' kids to be able to explore space. And if we ruin the environment, we can't do that. And that would be tragic, because my passion for space came when I was 10 years old and I watched Apollo 11 and I watched Neil Armstrong walk on the moon. And that magic that created that feeling in me that said, I want to do space. I want my kids and my kids to have that opportunity. And if the space environment is ruined, that will never happen. So just like we've seen laws come in to protect our environment here on Earth, we could also see laws come in to help protect space and the environment around Earth, with the hope of preserving the wonder and the beauty of the night sky for generations to come. Aliens contacting us might seem like science fiction, but now new mysterious signals from outer space are intriguing scientists around the world. This signal is so bright that it was completely unlike anything we'd ever seen before. It's not crazy to think that radio bursts could be created on another planet. What causes them is one of the biggest mysteries in physics. Now, linking strange signals from space with alien sounds a bit like something cooked up by a conspiracy theorist. Yes, this is real science. It's the job of an astrobiologist to figure out where in the universe is habitable, and if possibly intelligent, life could have developed there and then contacted us. In fact, in 1961, pioneering astronomer Frank Drake organized a now infamous secret meeting to try and figure out how many civilizations like this exist outside of our own. So we start out with the rate of star formation. Multiply that by the fraction of stars, which actually have planets, habitable planets in each system, by the fraction on which life develops, the fraction by which intelligence appears, by the fraction of those which actually give a detectable technology. This rate times the average time that these civilizations remain detectable. N equals about 10,000 detectable civilizations at present in our galaxy, the Milky Way, calling themselves the Order of the Dolphin. This group of award-winning scientists set out on the hunt for this huge number of civilizations that they thought could be out there. Oh, I believe very strongly that they are out there. We can be very, very wrong, and yet there will be many, many detectable civilizations. From secret government agencies to Nobel Prize-winning scientists, the search was on for weird first. There was the WOW signal in 1977, detected by the Big Ear radio telescope in Ohio. The signal was strong, about 72 seconds. But more importantly, it was detected in something known as the hydrogen line. That was significant because at the time, astronomers thought that if extraterrestrials did exist, they would use that frequency. The astronomer Jerry Ammon was so excited that he actually wrote the term "wow" on the printout. Very quickly, it was dismissed by astronomers as actually coming from a comet. Then, in 2007, came a detection of what would become the biggest mystery in physics, something that could have been a game changer in the search for aliens. My student showed me this signal that was so bright and apparently so far away that it was completely unlike anything we'd ever seen before. Then we realized this is just impossible, unless a civilization is way more advanced than we are. Scientist Duncan Lorimer and his team had found what we now call fast radio bursts. They're incredibly bright radio signals, so bright that they can't be coming from any naturally occurring phenomena on Earth. They have to be coming from outer space. Quite frankly, it was unlike anything I'd ever seen before. Yet it had all the hallmarks of a signal that was coming from deep space. I did think that it could be a signal from an extraterrestrial civilization. We create signals like that on Earth, so it's not crazy to think that radio bursts could be created on another planet. So it was a groundbreaking time for physicists, and with this new data from Lorimer, the burning question everyone still had was, now the problem with the Lorimer burst was that it was just a one-off, and how do you prove a one-off is real and not just some noise or some random signal in your detector? Well, it helped when other scientists around the world started detecting signals just like it. They were coming from all over the sky and they were clearly real. So it was a breakthrough moment. Now, although this seemed really exciting, it meant that there were probably much more likely explanations for what was going on. We observed binary systems of two neutron stars that are in orbit around each other. And when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they are going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. When you look at the energetics of these events, you can easily explain the FRB energies with them. You can also explain the durations of the FRB pulses with the expected durations of these merger events. So it's quite a plausible explanation. Neutron stars are some of the most energetic objects in the universe, second only to black holes, and you need something really energetic to produce a fast radio burst. Now, astronomers recently have discovered a fast radio burst coming from a magnetar in our own Milky Way galaxy. A magnetar is a special type of neutron star that has a very high magnetic field. And while this is really exciting that we finally might have an explanation, it means that aliens producing FRBs becoming a lot less likely. Now that fast radio bursts are real, it comes back to the point where they could be caused by aliens. So if I were looking for a signal from an extraterrestrial civilization, I'd be looking for it coming from a single point in the sky. Here we have a population of sources all over the sky, which implies that the aliens are all over the place, all over the universe. That just seems highly unlikely to me. So we're one step closer to solving the mystery of fast radio bursts, even though it's looking likely that they're not the alien signals that everyone was secretly hoping for. But as a scientist, I reckon, never say never. We'll always keep observing the sky and to think, in our lifetimes, we've got a great chance of discovering alien life somewhere out there in the universe. We've done a great deal of searching in the last 50 plus years, and we've learned that we're going to have to search perhaps 1,000,000 stars and countless frequency channels before we have a good chance of success. If I had this to do all over, I would still do it. And in fact, I'd probably put more time into it because I've come to realize that's what's required to succeed. And to me, that time is not time wasted because the eventual discovery is of such importance that it justifies not just one human life being dedicated to succeeding, but many. This weird creature might just be the best living explorer in the universe. We took him into space, put him on a satellite, opened up the door, set him outside, exposed him to extreme temperatures, vacuum, right, hot, cold, huge radiation, and they come back alive. This is the tardigrade, often called the water bear, and you can probably guess why. And they might even hold clues as to whether life on Earth arrived from outer space. These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth. Could they even be the origin of life themselves? So, what is a tardigrade? They're aquatic microscopic animals, barely visible to the naked eye as they're transparent and only about 1 millimeter long. They also love mossy conditions, which has earned tardigrades their adorable nickname, moss piglets. Tardigrade means this Latin name, slow stepper. Tardi mean slow, and grade it refers to foot. You can start to see he's got long, thin filaments coming off his body, and some actual more almost look like horns coming off his head that he uses in feeding. Yep, my brain is melting a little. So why are these moss piglets the ultimate space explorers? Well, despite being water-dwelling creatures, they have a special process of morphing or adapting to hostile surroundings like radiation or freezing temperatures. By drying themselves out, they can cope with all kinds of nasty conditions. As that sample jar starts to dry out, as that specimen starts to dry out, what's cool about these guys is they can survive that extreme desiccation, drying down to like a crispy little booger. It's called a ton. They roll up into a special tight ball, essentially. They're like a roly-poly bug almost, and then go through a series of radical chemical changes in the cells in their bodies to deal with this loss of water. Being in a ton form, tardigrades are as far from alive as you can be, but give them a splash of water and they spring back to life. What better place to test the robustness of a ton-state tardigrade than the freezing sprawls of Antarctica? We extracted them from soils in Antarctica, shipped them back here frozen solid, and they've been frozen solid here at least -60 since 2012. Holy moly. It's mind-blowing, dude. It's basically the same community that I saw when I collected them in Antarctica. We put them in a tube, froze them, shipped them. 4 or 5 years later, we want to study them, right? Pulled them out. We thawed them out. And now, what I'm seeing now looks almost exactly like what I saw when I was looking at them like fresh in Antarctica. So they can survive the most extreme conditions on Earth. But what about in space? Byron and his colleague Carl took them on a special outing to the International Space Station. Took them into space, put them on a satellite, opened up the door, set them outside, exposed them to extreme temperatures, vacuum, right? Hot, cold, huge radiation. And then when they brought them back to Earth, they did what you're seeing here. They dumped some water on them to see if they actually reanimated. Voila. They take the water up, man, and they start, right? They swap it out the molecules, and like a machine man, you add the water to it, they take them up, the cells start to do their thing again, and they come back alive. It always blows my... Look, I'm an old fat dude, and I've looked at these 100 times, thousands of times, millions maybe? You're not that old. Well, and then when I actually look at them under the microscope every single time, I'm like, dang, that's cool, man. Just like that, the mighty water bear enters tune state and navigates brutal conditions that would kill almost every other living thing. So if we know they can survive in space, and we know they survive on Earth, could it be possible that these space explorers traveled between the two, possibly even sparking life on Earth? When the Israeli space agency Space IL crashed their lunar lander Bereshit in April 2019, one scientist began to wonder, could the colony of tardigrades they had on board have survived? And could they survive a crash landing to Earth if they hitched? A ride on a meteorite? Alejandra Traspas-Muina of the University of Kent set about replicating the Bereshit crash and the kinds of pressures that this little batch of bears would have experienced by firing them out of a gun. Okay, so not quite a gun like that, more of a lab-based gas gun. Alejandra recreated the moon's conditions in a chamber and then fired the tardigrades into sand to recreate the impact that they would have had on that fateful day. Knowing how fast the spacecraft from the Bereshit mission crashed, we thought, well, let's try different speeds up to 1 kilometer per second, which, if you think about it, if just to get it into a daily activity, just think you're in your car and your car starts going faster and faster and faster, up to 3,600 kilometers per hour. So this is how fast tardigrades were shot. So we started with 0.5, which they all survive. 100% survival. So that's great. We researchers happy, tardigrades happy, and we kept going. We went up to 0.7 and they again survived. Then we went up to 0.9. And unfortunately, at these speeds, tardigrades couldn't make it, which means they didn't survive the Bereshit mission. But this isn't the end of tardigrades in space. Alejandra's studies continue. She and her team are testing whether they could survive in the water plumes or the icy surfaces of the moons of Saturn and Jupiter. These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth. I do not believe life is unique to Earth, so don't write off tardigrades just yet. They and other extremophils could still provide the answer to the life we live today. The DART mission is designed to save Earth from an asteroid. DART is our first planetary defense mission, defending against asteroids like this one, Bennu. We're bombarded by almost 50,000 kilograms of space rocks every day. Most are tiny and burn up in the atmosphere as shooting stars, but some bigger ones can cause real damage. Like this meteor in Chelyabinsk, Russia in 2013, which exploded with the power of 13 Hiroshima bombs, and that was only 17 meters wide. By comparison, the asteroid that killed the dinosaurs was 10 to 15 kilometers wide. And now there is another asteroid on its way. Bennu is about 0.5 kilometers wide, about as wide as the Empire State Building is tall. Between the years 2175 and 2199, there is a 1 in 2,700 chance of Bennu impacting Earth. Doesn't sound like much of a risk, but if it does hit, it will have the power of 80,000 Hiroshima bombs. But don't worry, NASA and the European Space Agency are on it. Enter DART, the Double Asteroid Redirection Test. Developed and led for NASA by Johns Hopkins University Applied Physics Laboratory, it does what it says on the tin. Really? At least that's the aim. DART is a demonstration of the kinetic impact technique just slamming a spacecraft into the asteroid. Brilliant. I'm Lindley Johnson, and I am NASA's first ever planetary defense officer. This mission will demonstrate that humankind doesn't have to worry about going the way of the dinosaurs. Why double? It is called the Double Asteroid Redirection Test because we are targeting a binary asteroid system called Didymos, which means twins, and impacting the moon to change that moon's orbit around the larger asteroid. The impact effects of an asteroid the size of Dimorphos, the moon of Didymos, 160 meters or so in size, the size of a small football stadium, would be an area of a small United States or a European nation. So it's important that we be able to protect life on Earth with this capability. DART is set to hit Didymos in autumn 2022. We'll be able to measure some of the impact from Earth, but another spacecraft is heading that way. The European Space Agency's Hera will arrive around 4 years later to assess the outcome of DART's mission. Okay, that's just wild, but why go to so much trouble when Didymos isn't even at risk of hitting the Earth? Because Didymos isn't the only thing out there. There are over 20,000 asteroids close to the Earth, of which 1,200 are considered high risk. Thankfully, people like Richard Kowalski scour the night sky to find asteroids before they find us. They're known as the asteroid hunters. As you can see on this screen is the sequence of 4 images that came from the telescope. These objects around the screen are not moving, so I know that they're stars, but this object in the center is moving, and thus we know that it's an asteroid. The importance of surveying for near-Earth asteroids is asteroid impact on the Earth is truly the only natural disaster that we can actually predict before it happens. The Earth has been hit in the past and will be hit again in the future. What we'd like to do is to be able to discover these objects before they hit the Earth. Observations collected are all sent to the Minor Planet Center, and if they are asteroids that could come near the Earth and be a potential impact hazard, that information is sent to the Planetary Defense Coordination Office at NASA. If an asteroid is a more immediate threat of impact, I actually get a text notification on my smartphone. At NASA, we're kind of the Uber asteroid hunters, maybe, is what you could say. So what would happen if an asteroid did hit Earth? Well, we all know impacts leave craters, but what else happens? Because it's not just the collision itself that would cause devastation. So for this experiment, we're going to fire this tiny 1/4-inch aluminum sphere at very high speeds, up around 5 kilometers per second, and then we'll see what type of crater it produces. So we use sand because it records the shock effects very clearly. Pete Schultz uses super high-speed cameras to capture every detail of the impact and aftermath. And high voltage, and paddle is in, warning lights, and rolling. The ball travels 15 times faster than the speed of sound and, like some asteroids would, incinerates on impact. Oh, perfect, perfect, perfect. Now we're seeing the fireball come in. It's brighter than the sun, and then kapow. It hits the surface. Geez, this whole region downrange would have been incinerated. It would have been incinerated just by this plasma, this exploding vapor plume engulfing everything. There would have been winds that would have been going so fast it could pick up houses and spread them hundreds of kilometers away. This would have been Armageddon. So all eyes are on the DART mission, and there are a couple of other asteroid deflection ideas floating around too. Some of them are wild. Here are some of the top ones. 1. Nuke it. Very Hollywood and probably the first thing you thought of too. Great in theory, but could result in radioactive debris raining from the sky. Not ideal. 2. Gravity tractor. Sounds very space farming, doesn't it? The idea here is to fly a device next to an asteroid so it slowly pulls it away from the Earth's path. This offers a lot of control, but it might not be effective for anything. Over 500 meters in diameter. 3. Paintballs. Yep, you heard right. Paintballs. Personally, my favorite suggestion. First, the act of shooting the asteroid would deflect it, and also using white reflective paint means that the force of the sun's photons would theoretically push the asteroid even further off course. The downside, it'd need about 20 years' notice for it to work. So we've got paintballs, tractors, and nukes, which might all seem like crazy ideas, but they're serious contenders. For now, though, it's all eyes on DART and its mission to save the world. If you've made it this far, your brain is either fully charged or pleasantly melted. Don't forget to subscribe for more dream-fueled deep dives into history, science, and absurdity. This is Dr. Weird, signing off until the next mystery whispers your name.